Everyone is awake now? Good. All right, thank you. I'm going to talk about producing OGC API features layers from Django. My name is Denis. Rouzaud is a bit difficult in English indeed. I'm a QGIS core developer for about 12 years. I'm with OpenGIS for 7 years, and I'm not a real developer. I have a geomatics background. I work for OpenGIS. We live love for open source solutions. We are historical developers of QGIS. We are the creators and the maintainers of QField and the Android application for for QGIS, sorry. And we have a service around it, which is called QField Cloud for the mobile data collection and integration. So the topic of this talk is about trying to use new solutions for issues we face with the SIG database model approach. I'm going to come to that again. And the idea is to use Django ORM and to use web services to interact with the data. I'm going to show some results and further steps. I do have two questions for you to feel a bit the audience. The first one is who has already played with Django? So maybe if you can. Okay, so that might be a bit easy for you, but we'll see. And who knows and who has played with OGC API features? Thanks a lot. Okay, so what issues are we facing with business logic applications where we use SIG database approach? So the SIG database approach is basically the idea that all the business logic holds within the database. I'm going to use a very small example for this presentation. Let's assume we have a network of pipes, water pipes, on which we put valves, and the valves are closing the pipes. I have a small demo in front of the building. So basically, the pipes are blue if they're open. They have valves on it. I close the valve, then the pipe is getting closed. That's pretty basic. And what we were doing usually for this kind of problems was to use PostgreSQL database and use QGIS as a client. Basically, we have two tables, pipe and valves, nothing fancy here. And basically, we're using triggers to update the data accordingly. So holding all the business logic within these triggers. So here in this example, one trigger to assign the pipe to the valve when we place it, and another trigger to update the pipe whenever we close the valve. So we close the valves, it updates the pipes connected to it. Makes sense? Easy, cool. Thank you. So what are the issues we're facing with this approach? First, after some time, it proves to be quite difficult for the version control and change management. We also observed that unit testing is seldom, if ever, implemented in these solutions. Modularization and customization is very complex and costly. Usually you have one solution and you have several instances for different clients, and each client wants some customization, some specific implementation for its needs, and it's quite difficult to maintain several instances of the same solution. And I think I can safely say that here that SQL has poor code readability. I don't take too much risk at Python. I see some faces, but that's a bit subjective, obviously, but I prefer to read Python than SQL. Okay, so what is the ID here? So that's not mine, the ID is from someone else in the audience, a former colleague. The idea is to use Django ORM to hold the business logic, and on top of that, put some web services to interact with the data in a client. So the business logic in Django. So I don't think I have a huge need to introduce Django here, but what does it bring for us in this case? DRM, so object-oriented approach that we don't have with Postgres. The data is held in the database, PostgreSQL. We have GeoDjango, which brings the spatial management. We have migrations of the data model, which comes for free with Django. We have an authentication system. We have built-in model-based permission, so models are class in Django, and modularization of the solution is quite easy. So whenever if I use that small example that we have here in Django, I have my pipe class with ID, the closed Boolean field, and the geom coming from GeoDjango. Same with the valve, and here I have this small code snippet on the save, which basically is doing the same than the trigger before, getting the pipe. So we reference which pipe is connected to that valve, and whenever we change that closed status on the valve, the pipe is getting closed or open. And if you have several valves on it, it's the combination of the several valves. And I can show here a small example playing it in the Django shell. So I'm creating the objects, the points for the geometry, creating a pipe, creating a valve that will be on a vertex of that pipe. I try to see if that pipe is closed. Now I'm turning the valve to closed, saving it, and my pipe is now closed. So that's what we wanted with this small example. So now interact with the data through web services, because we don't want to play with the shell for our application. So the idea is to use OGC API Features. That's the OGC API standards for building blocks, special blocks. And we'll use the features one, so which is, all OGC API standards are built on top of OpenAPI, and the OGC API features is the one for playing with features, interacting with features. So how does it look like? It's basically GeoJSON. So if we get the URL of our pipes, we get here the GeoJSON of the features of our pipes. So 2 pipes here. Yeah. So now that we have that, so OGC API Features is on top of OpenAPI, and we have Django REST framework which allows the schema generation, which will allow us to basically build these endpoints for building the OGC API Features endpoints. So the whole idea is basically to create a Django application to produce these OGC API Features endpoints based on top of the models. That's what we've called Django OAPIF, and that's the library we've brought. Now maybe some are thinking, what about PyGeo API? Do you know about PyGeo API? Yes? Okay. So mainly PyGeo API is building endpoints on top of data sources, be it CSV, JSON, PostgreSQL, but it does not connect to the Django models. So if we would use PyGeo API, we would lose all the logic the business logic that we put into the Django ORM. So Django OAPIF, as said, is a Python Django application. It's open source under MIT license, and it provides a simple decorator that we put around our models. I take again the small example here that we have of our pipe, and you see that I import the decorator, put around it with specifying the CRS, And that's basically it. And now I have my endpoints available by doing only that, and I can browse the endpoints. I see the two layers, pipes and valves, and I can go to my items that I see here. And so that you believe me, I've also done that in the zoo in Basel to bring the water to the elephants, to stay in the topic. So, so what? Django API, it allows interaction with the Django models through web services. It brings all the power tools from Django, authentication, user management, and so on. So it's a huge ecosystem of well-maintained package, and side effect, it also opens the door for any web application, basically. And for instance, here is, you know, the Django admin modules that comes for free. For free, meaning like with a few lines of code, you have this, and basically I have a web interface to browse the items, my layers, and I can even edit it, show them on the map, and that's coming for free. So that's really something apart from the endpoints that we were having before. Now I also have a web application next to it where I can go through my layers and items. And this whole project, we are working on it at the moment for trying to develop a solution for electricity networks. And that's an example here, for instance, that's a proof of concept. We have trenches in which we have tubes, in which we have cables. And basically you see the trench here in QGIS with the OGC API Features layers. The tubes, and I have this profile which is on a web page showing the tubes and the cables in the tubes at the location I've asked for that profile. So how cool is that? Maybe that's not obvious, but it's a huge benefit for people developing such applications with business logic. We would be super happy, but of course there is some drawbacks. And the first drawback is what you're gonna see here. So I have a polygon of the Swiss municipalities, and I open it in QGIS, and that's not super snappy. We've been talking about millions of points shown in 3 seconds in the former talks. We're far away from that here, and that's the main issue we have, the main point that, for that. And here I've clicked on open the attribute table, and that's going to take even more time to be shown. So I'm going to skip that, but basically it's not very snappy. Yep. Yeah, so here it's obviously the time of the slowness is depending on the complexity of the data, and that's why I've shown with these polygons, because it's a bit complex. On this graphic you see the fetching time depending on the number of features, and this line here is the Swiss municipalities. Here you have lines and points, and here you have no geometry layer. And basically what is expected is it's linear, obviously, but if you see here the complex polygon, it's about 10 times slower than a layer without geometry. This bad performance is mainly due to the serialization of the objects in the Django ORM, because Django accessed the DB and is creating instances, Python instances for all the objects, and serializing the geometry and sending that through GeoJSON. So that's pretty inefficient. And on the other hand, on the client side, the example I've shown, QGIS is really not optimized yet for these layers. Mainly the attribute table, for instance, it's not paginated, so it waits for all the data to be loaded to be shown. while you have an endpoint which is paginated. So it's a bit not optimal at all. So now what can we do? Here we've shown that we can move part of the serialization effort to the database. So instead of doing the GeoJSON or JSON serialization in Python, we ask the DB to do it for us. That if we only do the geometry, we're about twice time faster. And the idea is probably to move everything, the whole serialization to the DB. But still, that won't bring, even if it's 2 times faster, if you think about the layer before, that won't solve the issue. Another thing is that Django DRF is known to be quite slow, and there is quite some interest around Django Ninja, which is a Rust implementation and possibly faster than Django DRF, but it's really not up to date feature-wise comparing to Django, which has Django DRF, which has a lot of things like model-based permissions, which are well handled. Basically, if we move to Django Ninja now, we would have to rewrite quite a lot of code, which is not the currently what we want to do. We want to prove that it's working well, the idea to work like that, and probably wait a bit for Django Ninja to be a bit more feature compatible with DRF. Then it's also a matter of improving the user experience in QGIS. The data provider is not very fancy. You've seen the progress bar showing on top, which is not very nice. I've talked about the pagination in the attribute table. There are also some other perspectives, like using better geometry format rather than GeoJSON, because you're serializing it on the back end, and then QGIS receive it and it creates again a VKB geometry. So that's a bit of waste of energy. And the other thing also is we try to think a bit differently, because basically our solution is API first, client agnostic. So we could also at some point try to think about getting rid of QGIS or bring the web within QGIS. Maybe the attribute table, we would be better using the web application. So showing the attribute table as a web application within QGIS, things like that might actually be more efficient and even more for a better user experience. So in the end, use it where appropriate. I think, as shown with the polygons, that's not what you want to do. You want to use it for simple geometries, point lines, and basically complex data models which have relations and business logic. For us, it has a huge potential at low cost because of the Django ecosystem. You can have many, many things coming with small development. As said, this is open source, so if that brings any idea to anyone in the room, feel free to contribute or contact us. And here is the link to Cablo. That's the POC or project we're trying to push for electricity network or any solution. Small thanks to the 3 Swiss municipalities which have sponsored this POC. And yeah, here's the repo. Thank you.
Okay, thanks very much. We have some time for questions.
Hi, as far as I know, there's already existing library plugins like DRF GIS. Why do you choose to use the one you mentioned?
So this is based on top of Django DRF, but there are DRF GIS, sorry. But there are a few things on top to actually produce this, to be compliant with OGC API features.
Oh, so it is on the top of that.
Yeah,
Okay.
it's based on top of Django REST framework keys.
Okay. Thank you.
So when you moved your data to PostGIS, did you try returning vector tiles directly from a database instead of GeoJSON to solve your performance issues?
You would lose the Django, but basically you would produce the tiles as one time. That's what you said, or?
No, you can just return, you make a view of your data and return the vector tiles to show them in QGIS and only use Django once you click on a feature, then call the API.
That's the idea, a bit probably, to have an hybrid solution. Even actually we can connect directly to the Postgres layers. That would be one way, but basically you lose the authentication coming with it, the model-based permissions. You lose, it's a bit of a trade-off. Yeah. No? Not convinced, or?
Anyone else? Okay, in that case, thank you very much.
Thank you.